Let's start off with something really easy like number 12. We're looking at sine of 14 pi over 3. First of all, which way are we revolving? We're revolving counterclockwise. And then, what family of angle does this come from? It's a type of pi over 3. So that means that sine of pi over 3 is what? What is sine of pi over 3? It's rad 3 over 2. Now it's just to determine, is it positive or is it negative? So we draw our little mini unit circle here. This is 3 pi over 3. 6 pi over 3 here, so I go 12. And then 15. But if I go 15, have I overextended or am I falling short? I've overextended 14 pi over 3, so I need to backtrack 1 pi over 3, which is right here. So is sine positive or negative in that quadrant? It's positive. So that's where we are. Let's do something a little harder than that, like let's try number 18, secant. 25 pi over 6. Now, we're dealing with secant, pi over 6. Now, secant is reciprocal of cosine. Cosine would be rad 3 over 2, but we're dealing in secant, so what would it be? 2 over rad 3. Now it's just, is it positive or is it negative? So now we go 12 over 6, and this is 6 over 6. So we're revolving counterclockwise, so it'll be 12, 24. I have fallen short. I need to go up 1 more pi over 6. So right here, is it going to be positive or is it going to be negative? Whoops. Positive. Let's do another one here. Cosecant of 9 pi over 4. That is number 28. Okay, it comes from the family of pi over 4. Sine of pi over 4 is rad 2 over 2. What's cosecant? 2 over rad 2. Split. So now, this is an 8, this is a 4, 1. We need 1 more pi over 4. Are we positive or are we negative? We're positive. That's how you do those problems. Okay, let's do something like number 52. This one's easy. So we're going to find all 6 trig values if sine theta equals 4 over 5. Well, the first thing you want to do is you want to draw a triangle. A right triangle. Theta can be here, it can be wherever it wants. Sine is opposite over hypotenuse. What is the third side? How big is the third side on this one? 3. It's a piece of cake. 3, 4, 5 right triangle. Okay, so now we have sine theta, cosine theta, tan theta, cosecant theta, secant theta, and then cotangent theta. I highly encourage you guys to find the first 3 first, the regular trig function. This is 4/5. This is going to be 3/5, and this is going to be 4/3. What are the reciprocal trig functions going to be? What do you think? Julia? 5/4, 5/3, 3 over 4. Nothing hard about those problems at all. Raise your hands if you need help converting degrees to radians and back again, if you don't remember how to do it. Okay, so let's take a look at something like 7 pi over 12. Okay, you multiply it by something. Now remember, Chris, you see how it's pi on top? In order for the pi's to cancel, I need to have a pi where? On bottom. Now, pi is associated with what type of measurement? Is it degrees? It's radians. Right? This is 7 pi over 12 rads, right? And then how many degrees are in pi radians? 180. 180 degrees. So, remember to piss me off? The words are going to cancel each other out. What else is going to cancel each other out? The pi's. What else? 180 and 12. What's 180 divided by 12? Let's see. 6 into 180 is going to be 30. 15? 7 times 15? 5. Let me see here. 105 degrees. And then for Chris, it would just be reversed. If you were to say try number 94, negative 315 degrees, we'd multiply it by pi radians on top over 180 degrees on bottom. The words cancel each other out. 315 into 180. Okay, so that's looks like 7 pi over 4 negative radians. All right, let's do a couple of graphing ones. Ooh, 114. We have never seen one like this before. Does it make sense that the inside really is this? It's really 1/2 theta. Now I'm going to factor that 1/2 theta out, so it's going to be y equals 4 sine 1/2 theta minus 3 pi over what? 2 minus 2. If you guys don't know why, multiply that back in. 1 times 3 is 3. 2 times 2 is 4. All right, we got to identify the 4 things: the amplitude, the vertical shift, phase shift, and the new period. Amplitude is 4, vertical shift is -2, the phase shift is 3 pi over 2. What is the new period this time? Chris? No, it's not pi. 4 pi. Which is really 8 pi over 2. Michael, did I lose you somewhere? Okay, remember, normal period for sine is 2 pi, right? Divided by the frequency found. The frequency's here, yeah? Divided by 1/2 is equal to 2 pi divided by 1/2, which is equal to 2 pi times 2. Yeah? That always throws people off. Okay, so now we have enough information to graph this thing. Whoa. Oops, I don't know why I did that. Okay, it's down 2. How far low is this thing going to go? -6. How far up is this thing going to go? 2. Sine looks like this. Where did it start? 3 pi over 2. Where does it end? 11 pi over 2. Midway point, 14, that's even, so 7 pi over 2. 10, that's even, so 5 pi over 2. 18, so 9 pi over 2. Where's the y-axis throughout all of this? Far left, before everything. That's how you graph it. Okay. All right, that should be good for now.